Thank you. Hi everyone. That's my introduction done. So I work at the Open University in England in the Learning Experience and Technology Department. So today I'm going to be talking to you about OpenSTEM Labs. Okay. Oops. So I'm just going to go through with you what OpenSTEM Labs is in the first place, because you've probably never heard of it. And I'm going to be walking through the recent development we did. It's August, September time earlier this year. And then I'm going to just give a whistle-stop tour of the labs and a couple of the experiments within those as well, just to give you an idea of what's on offer for our students. So, what is it? Well, it was originally developed in 2013 and it was coined the Open Science Laboratory. It is a Moodle-hosted website and the aim really was to challenge the traditional university STEM model of teaching, which is where students and teachers need to be co-located in a lab during office hours. So predominantly our audience are Open University students. However, we do have other educational institutions that have access to our experiments. And we also have informal learning available for students that are not registered on Open University courses and can get a free access login. And really this is for pre-university students and undergraduates as well. And so the aim really of Open Science Lab when it was first released was to provide practical facilities that enable interactive and collaborative learning of STEM subjects. So group work is possible through this platform. We wanted to achieve an inclusive approach to practical work without requiring students to attend a physical lab. And we also wanted to enable our students to learn through remote interactions with real equipment that is based on campus. And therefore exposing our students to a range of practical equipment and tools in a realistic setting, which increases the utilisation of our teaching and lab resources. So what do we provide? Well, we do have real pieces of equipment on campus that students can connect to remotely via the Moodle hosted platform, and they can conduct their experiments. So this is an image of a pendulum that we've got sitting in our lab. I'll go into that a bit more detail in a bit. We use virtual scenarios for students to study using data collected from live experiments, so they can enter their own parameters into different virtual pieces of kit, and they can determine their results. We've got real data to compare and contrast different samples, for example, rocks and fossil imagery, or microscope slides of cells and plant life. We also use quantitative data sets, videos, samples, that sort of thing. And then we also record live labcasts from our lab, so students can watch experiments happening live, which are also recorded so they can come back to those experiments at any time as well to support their studies. So this is a list of all the equipment and kit that our students can connect to, depending on what courses they're studying. And as I said, some equipment and pieces of kit are available to other students as well. Just to call out there, we do have a Mars landscape on campus, which is essentially a big shed full of sand that's sort of mapped out to look like a Mars landscape. Students can work collaboratively to navigate a mini Mars rover across the landscape to support one of their assessments. So, as I said, it was redeveloped, it was just released at the end of August this year. So why did we update it? Well, it was 10 years old, and as you can see, it does look like it's 10 years old. It was using ex-Moodle code-based theme and old course format model. But really want to align with current user expectations. We know they've got a lot higher since COVID, lots more people engaging with online learning, and the old site really was clunky and not suitable for our students anymore. Accessibility reasons, so the old platform wasn't fully accessible, so it's now been updated so that it is accessible according to the current WCAG 2.1 guidelines. User expectations, as I said, usability, wasn't an intuitive site to use. We've now made it a lot easier for our students to find the experiments. And it also wasn't mobile friendly. What we're offering is science anytime, anywhere, so we need to be able to make sure that whatever devices our students are on, they can access these experiments. So with regards to scalability and flexibility, well, when this was first introduced, there was only a few experiments. Since then, we've now got over 200 different interactions for students, making it quite difficult for not only the tutors to find their information, but also the students. So we need to future-proof that, and as more experiments are being added, we need to make sure that we can facilitate that for our faculty. And flexibility, so we've made it a lot easier for our faculty to be able to add experiments and edit experiments dynamically, giving them more control over their content. So if you're at the MoodleMoot in UK and Ireland, Sam Marshall, the lead developer on this project, did do a presentation about a lot of the technicalities to do with this development. Caveat, I'm not giving technical information out today, I'm not a developer, but if you were there, that's the QR code to his presentation in case you missed it. So what's changed? Well, you'll notice that it's changed from Open Science Laboratory to OpenSTEM Labs, and that's to incorporate the vast number of experiments we now have that sit under the whole umbrella of STEM rather than just science. This is a Moodle site homepage. We didn't have that before. As you can see, it's been highly customised using a theme plugin. And so we now have 4 distinct labs within this site. So we've got a science observatories, the Open Science Lab, Open Engineering Lab, and Open Health Lab. We have a lab page, which is a Moodle course page, and this is where we showcase all of the experiments within those labs. This actually hasn't changed too much because we had to be very aware of the fact that we had these existing experiments that needed to be ported across quite simply to reduce the amount of development required. So the only thing really we've changed here is the ability to add favourite experiments. Again, something that users expect really when they come to this sort of site, to be able to find their experiments that they like really easily. And it also helps our tutors out as well, trying to find their experiments that they're working on. And the use of dynamic capabilities as well to edit experiments and lab information so that it's just quicker and easier for us, for our tutors and for the faculty to be able to edit those experiments. And this is not just relevant for this page, it's across the whole site as well. And then we have the experiment page where students can actually access their experiment. So really this is sort of a different coat on the same information. Again, we really had to be mindful of the fact that we didn't want to be doing too much to this to move it across. However, this is something that we're going to be looking at in the future to change how this looks and feels for our students as well. So just talking about the user-centered approach really that we take. So historically with this sort of kind of massive redevelopment and refresh, accessibility sometimes gets left towards the end. And so really we've consulted with our accessibility experts right from the beginning and our UX designer so that we didn't take the approach of doing all the developments, doing an accessibility audit and finding actually there's loads of problems that need to be redeveloped. And so when we came to do the accessibility audit at the end, it was fully compliant, the platform itself was fully compliant, and we knew that we could release something that was suitable for all of our students. And when we're talking accessibility, we're talking neurodivergent students as well as those using assistive technologies and just sole keyboard users as well. We also get our content designers involved that are extremely good at using the right language that talks to our students. So in all of our guidance, we have to be very mindful of the fact that we not only have OU students, but we have students coming from outside of the OU that might not know the OU speak, as which is all acronyms, by the way. I don't know if you've ever seen any OU sort of paperwork. And so they're, as I said, really good at listening to what students say, listening to how they describe science experiments and reusing that language so that it makes sense to them. And then we've had faculty engagement, again, right from the beginning to identify what their problems were so that we could create a solution that's right for them, but actually showing them their development every couple of weeks so they could be really clear about what they were getting at the end and not surprising them with something that wasn't right for them at all. We also did some external testing with our external research partner. So we asked our UX designer to make a working prototype of the page, and then we got students, not only OU students, but actually other students that are interested in STEM subjects, to test the page. We gave them a list of tasks to be able to complete, and we observed them completing those tasks to make sure that what they were trying to do was easy for them. They also use something called an emotional response tool. So here you can see the sort of a heat map where the dark green are the most popular answers to the questions, light green being the least popular. And the main thing that came out of there was they felt the site was trustworthy, clear and professional. But what it also highlighted to us were that there were certainly areas where students struggled to complete some of the tasks. So what it's done is give us a really clear future roadmap of what we need to look at, which include filtering capabilities, the possible use of templates when it comes to the experiment pages so that they're really consistent from experiment to experiment, and again, use of language in the guidance for the experiments themselves. So when it comes to complexities or something like this, again, I can't list all of the complexities because there are hundreds of them. But I suppose one of the main ones is that we have multiple user types. So as I've been saying, we have students that come directly from their courses. They're OU students, they have their logins. We need to make sure that the two systems spoke to each other, from our main course pages to the OpenSTEM Labs. We have students coming in from other education institutions, and we have students that come in that are just informal learners. So we have to make sure that all the roles and the permissions for those were correct. And thankfully, we have an excellent developer that has done that for us. We also have to therefore make sure we've got lots of paths into and out of the different labs and the homepage. So the use of the logo at the top, really clear use of the breadcrumbs there, and then also a drop-down menu. So students have got really easy ways to be able to navigate around the site. And again, as I said, making sure the guidance and the wording on there is really clear so students actually know what they're landing on when they get there. There's also multiple different experiments, which sounds quite obvious, but the fact is we have experiments that are available within the platform themselves. We have pieces of kit that are accessed to via various different URL routes. We have all of their content that is available on the STEM faculty's own servers. So that causes lots of different problems when it comes to accessing all of those and the security that there is around that, which is why we had our STEM colleagues involved really early so they can be involved in the user acceptance testing to make sure all of these experiments worked right from the very beginning. We also use a booking system so students can book their times onto the experiments, and this in itself is a really complex development. So we have instances where students can book one piece of equipment on their own, they can book a piece of equipment with other students, or we have 10 pieces of equipment that can be booked at the same time by individual students. So that in itself is a massive headache, which is why we've decided to split the developments in two, and this is actually something that's coming later on in the year. So this is an image of the old, or the current, I should say, system. And then the content. So whilst the platform itself, we own the Moodle platform, the STEM faculty actually own the experiments and the content. So again, it was about being really mindful about what they have and making sure that it ported across accurately in a way that was, again, going to work for them and their students and the experiments themselves. So I'm not going to go through all the names, but this is just gives you an idea of the number of people that's been involved in this development to get it released. So it's a huge piece of work. And so just to give you an idea then of the labs and the experiments, really, just to have a walk through. So the OpenSTEM Lab, the QR code here goes to the faculty website if you wanted to find out more about the lab itself. And then when the PowerPoint slides are shared, you'll be able to see the link there as well to the science lab. So this hosts over 100 practical experiments and engagements, and it's got over 100,000 hours a year of timetabled investigations for OU students. So this is an example here of an A-level virtual microscope activity. A-levels are pre-university levels, so hopefully, if the technology works, there's a little video. So this is open to the public. They can access this. There's over 93 different sections of animal and plant tissue that students can explore. They can magnify up to 20 times there. They can take measurements, and then they can record their data, download the images for their records. Just let that play. Okay. And then the Open Science Observatories. So this has just a small number of experiments at the moment, and they're centred around our 2 optical telescopes that we have in Tenerife. So again, as I said, acronyms, we're really good at them, COAST and PIRATE. We also have 2 weather stations, one that is on Tenerife and then one in Milton Keynes, so that you can compare different data sets of live weather at any time. And we also have an observatory as well based at Milton Keynes campus that students can book time onto and use. So there's the images of the telescopes there. These are used, so these experiments are used to support core OU teaching, but we do also offer free badged Open Learn courses. And so, you know, students registered with Open Learn can also access these telescopes, book time on them, and get their images as well afterwards. Then we have the Open Engineering Labs. So there's currently over 31 experiments there, and it serves over 600 students as well. So unfortunately, I can't show you a demonstration of this one because it's available for OU students to support their teaching. So as I said earlier, this is a pendulum activity, and this is actually an image of one of the pendulums that's on campus. So there's different levels available for students depending on what they're studying, and therefore different activities that they can do. But essentially students can use the interface within Moodle to be able to input their data, and then they can use a webcam to see what reaction that has on the pendulum, and then they can again record their results, change the parameters, and use that for their studies. And that's supporting our engineering modules. And then finally we have the Open Health Labs. So these mainly are experiments using our health sciences and other related qualifications. So we've got lots of examples of virtual cell and tissue microscope slides using real imagery. We also use real health data to examine behaviours of disease. So for example, you can look at external factors on health such as smoking. And there's a really cool activity where students studying particular modules can grow bacteria in a lab in different environments and see the reaction that it has in those different environments. And so this is an example of a spirometer activity, and again this one is open to the public, but it's also additional activities are used to support some registered students as well. This uses data collected from over 7,000 healthy subjects, and so what students can do here is enter different age, height and gender parameters, and they can see what the lung function is of those different parameters and compare those data sets, and they can also compare data from a smoker and a non-smoker, so they can see the impact as well that has on lung capacity. Okay, so that's it from me. Thank you for listening. Bit of a whistle-stop tour, but I'm here to answer any non-technical questions. Thank you.
Hold on.
Hello.
Maybe I can talk. No. We need it for the recording.
Excellent. Hey, Baba.
Hi.
I'm wondering, do you have anything about the chemistry or physics
There are, yes. So there are at the moment, but because, again, this was Open Science Labs and we've now got these new labs, a lot of those experiments are currently sitting under the Open Science Lab because of the way that it was set up initially. So that was a course, whereas now the courses have now been split into the 4 different labs. And so they will be moved across into different areas. Okay. So there are ones to support all of those subjects, but it might just be sitting in the Open Science Lab at the moment.
Okay, so another one to follow up. Is everything preset, or can a teacher or instructor set up an experiment for the student?
Can teachers set up the experiments, did you say? Is that...
You know,
so,
play with all the parameters, decide the solutions, whatever.
So you're saying can students set up experiments on that?
No, for the students.
For the
Can the teacher set up the experiment, the chemistry experiment, set up the solution, the measurements?
Oh, yes. So we do have, yes, so not the teachers themselves, it's done by the faculty. And then the sort of tutors will be there to support. But we do have, again, we've got sort of a chemistry lab and we've got the physical chemicals which are set up, and actually we do have teams go in to reset all the chemicals in the morning or whenever it's been used. So, yeah.
I see. Thank you.
Thank you. I just wanted to see how it's integrated with the gradebook, or how the data will be published to use for the research, or...
Is that the students' data?
Yeah.
Yeah, so at the moment it's exportable into CSV files, or it's a copy and paste, so we don't use gradebook.
Oh, you don't?
So, no, it's exportable either, as I said, CSV, or it'll be something that they can copy and paste into their own.
Just one for follow-up. It is integrated with external website, or is it just inside Moodle? The whole Open Lab that you have?
So the Open Labs is Moodle, but it is available externally.
Yeah. Thank you.
Yeah, so linking up to his question is actually for where the simulations are, or the simulations are they publicly available in like downloadable formats that you can either put somewhere else, or they are all accessible online?
No, they're all, so none of them are currently downloadable, so they're all accessible via that platform.